Okay, so I have Rumble started. I've got Beam started. Now I'm going in and I'm checking the audio to see if I can hear myself or not. Beam sounds good. Let me go in now and check Rumble. I've got to go into my content, open it up, see what it sounds like. Sounds good. Now X. Let's check that out and see if I can hear myself. X sounds good. Now I'm going to DLive. And the reason why I'm doing all this talking is because I've got to have something to hear while I'm doing my sound check. So here we go. Let's find out what DLive is. Just for anybody who's out there, DLive sounds good. Anybody who's out there who's curious, DLive, if you're on DLive and you use Rumble Studio, it will automatically do the stream for you on your channel so that you don't have to go and do your stream key and everything manually every time. So just so you guys know that. Everything sounds good on Twitch. Oh shit, I gotta go change the information around on my creator dashboard for Kick because I didn't change the stream info. So I'll get that taken care of right now. All right. Now, gaming with Infamous is what I've been using on my streams, but on YouTube, I am actually going with just gaming, and it's a podcast. So, just so everybody understands that. Okay, so we have gaming with Infamous set up on there. Now I have to listen to the audio. Okay, it's going good. I've got everything up and going. It looks good so far. I'm going to put Beam back on chat or on Studio so that I can see the chat. It gets a little bit complicated every once in a while, so I have to actually let me go in and double check with YouTube. Yeah, YouTube sounds good. And now I go back over and do Beam. So here we go. I have everything set up and ready to go. It looks good. Now what I'm going to do is put on a song for you guys to listen to while I go get my cigarettes and stuff like that. So if it will start. Let me see what's happening. My echoes in the dark is not wanting to live. Let me see what's going on there. It's supposed to be working, but it isn't. It's weird. I had something else that was doing that. Okay, that's not it. Okay. Let me go ahead and set this up again. Come into media. But the good news is everything is set up and ready to go. I've got 10 minutes. I'm gonna go grab me some coffee, soda, maybe, and even get me set up to smoke a cigarette. So I will be right back. Hope you guys enjoy. Okay, I am back. I have coffee and I did my cigarette smoke. It is time for me to get back into the show now and get ready. Do this. So, here we go. Hello, everybody, and welcome back to gaming or gaming with Infamous, whichever server you're on. That would depend on what the name of the game the stream is. Now, one thing I do want to point out is that on all the other streams besides YouTube, I am streaming under the name Gaming with Infamous. Now, on YouTube, I am going with a podcast live stream, and that is gaming, just gaming. So, and just also to point it out, this stream on YouTube is separate from my other channel, which is the one I regularly do for games. That one is Gaming with Infamous. This one is actually just Roger Hanson, and you can do that one at Roger Hanson 73. So I just wanted to clear that up. I'm trying to get the series for gaming fired back up and up to par. Right now, I am on the I think it's the 22nd episode for that one. I'm not sure. Yeah, it's the 22nd. So that means I'm wanting to do two more of them. And I'm good with it right now. I have pulled up a lot more information that I am working on, or I have been reviewing. So or going through with these streams, and right now I'm going through a review of it all. I want to apologize too about a lot of the problems I've been having with this series. I've been having issues with audio and things of that nature. So some of the streams haven't come out as good as what I'd hoped for, but I do have them going now, and um, it everything seems to be working. So, with that said, I also want to mention the fact that I am using Rumble Studios now, as well as Beam Studios, so that I can multi-stream across the different platforms that I am on. I am on Rumble, for one. I'm also on Beam. I'm on X, as well as DLive, Twitch, and Kick. So we have quite a bit of good stuff to or we've got a few good platforms, I should say, that we're on at the moment. So with that being said, let me go ahead and get a cool background set up so that you guys can see that, and I will get ready to go. So I left off talking about game logic whenever I did the last episode, and now I want to get into physics engines and talk about that. Now, physics engines are specialized software frameworks that simulate physical systems in real time or pre-rendered scenarios, which allows games to mimic the behavior of real-world physics. Now, these engines are critical in creating realistic environments and interactions. It also enhances immersion and also gameplay dynamics. Now, first we have to go over rigid body dynamics, okay? And that is something that simulates solid objects that don't deform when forces are applied to it. Examples of this could be like falling crates or rolling balls or character collisions, things of that nature. Then you have soft body dynamics. Now, these are model objects that can deform under force, such as, cloth and rubber, jelly-like substances, things of that nature. And that's used in games to simulate like clothing, flexible materials, or organic matter, things like that. After that, there's also collision detection. All right. Now that determines when and where objects interact, such as like characters walking into a wall or bullets hitting targets, things like that. Now there's two primary types. There's the discrete, and that checks collisions at specific time intervals. Then you have continuous, and that tracks collisions over time, and that's to prevent objects from like tunneling through each other, things of that nature. Now, after that, there's fluid dynamics. Now, fluid dynamics, it's basically states itself. You know what I mean? It simulates liquids, gases, and other flowing materials. It also influences things like smoke. Okay, so and fire too. So just be aware of that. Good examples are like water, where water splashes. Then you have smoke, and then you have fire, like I just mentioned. So now, after that, you go to particle systems. Now, particle systems are used to simulate small dynamic objects like sparks, rain, or dust, Um, and that's usually paired with fluid dynamics for like realistic effects, just so you guys know. Okay. So then, once you get through particle systems, you start getting into things like ragdoll physics, which simulates character bodies as kind of like interconnected rigid bodies, and that's for like creating realistic death animations and stuff of that nature. That's popular in games. Most games that you'll see that in is games like Grand Theft Auto and Dark Souls. You'll see a lot of that. Now, after that, there's also constraints and joints, and that's used to simulate relationships between objects, and that would be things like hinges and springs or ropes. It's used for mechanics like swinging doors or bridges or pendulums, things of that nature. So, besides that, there's also environmental effects, and that handles wind, gravity, and other forces that impact objects. It adds a lot of depth to the game world, like leaves blowing or objects floating in water or on top of water, things like that. Now, I know most of this because I usually use that whenever I play around with computer graphics on Blender. And it's pretty much the same concept, except for this is trying to create a game on a game engine, So that's basically it. And whenever I use Blender to create stuff, I can't take all the textures and transfer it over to a game engine like, what is it? I keep forgetting. It's Epic Games. Their real-time engine or something like that. Right now, I'm having a brain. Unreal Engine, that's what it is. Yeah. But I can't transfer that. So whenever I take what I have on Blender and I transfer it over to Unreal Engine, I have to recreate the textures and stuff like that on that application, even though I have it on Blender, Now, maybe there's a way of doing that, but I haven't been able to really work with it in that way. I haven't developed that great. or that far ahead, basically. I've had to recently work with A-Frame, and I know that there's ways of getting all of it transferred from one platform to another, because I've actually started um, using the settings in Blender. That's just the best way of saying it, and it's uh, it's a whole new learning experience other than getting on Blender and actually learning how to use Blender. Now I have to actually learn the settings all over again. So I do have somewhat of an understanding of a lot of the things that are going on here. So that's all I'm basically saying. And I hope that made sense to you guys in some matter or another. I just got into a little uh, little part of my show where I'm just babbling on, I guess. So after that, I want to kind of go over some popular physics engines. Um, the first one is the Havoc physics. Now that's used in like AAA games for like robust feature sets. It's usually found in games or franchises like Assassin's Creed or Elder Scrolls and Halo, games like that. And that's known. It's used because of its efficient and real time simulations. You have uh, PhysX, which is from NVIDIA. It's developed by NVIDIA and it's optimized for GPU acceleration. Now, this allows high quality simulations like destructible environments and fluid dynamics, which we were talking about just a little while ago. And you'll find that used in games like Fortnite or Borderlands. Now, after that, you have bullet physics. Now, this is open source and it's versatile. And it's frequently used in both games and simulations, including VR applications. It powers engines like Unity and Unreal. So that's that's where bullet physics is mostly used at. Now, after that, I want to go to Unity physics, and that's Unity, and it offers two physics systems. It uses Unity physics, which is lightweight, and then it uses Havoc physics, which is the advanced. Um, and Unity physics is designed for integration with Unity's ecosystem. So that's basically what that is. And it's like I told you, when you take something from Blender and you integrate what you've created on Blender and you put it onto Unity, um, that's basically what it comes to down to. It's supposed to it's designed for integration basically. So then after that, let's talk about Unreal Engine's physics. They have a built-in chaos physics. Um, Unreal Engine systems um, use it for handling destructive ragdoll and complex simulations. And we went over ragdoll just a second ago. So you guys don't know what that is, go ahead and hit rewind, go back and check it out. Now, after that, I also want to talk about CryEngine physics. That CryEngine physics focuses on visually stunning simulations, particularly for natural environments. It powers games like Crisis and a Hunt, Showdown, games like that. After that, there's Farseer Physics, and that's a 2D physics engine commonly used in indie games. It's simple and it's lightweight. Now, that's ideal for like 2D side scrollers or puzzle games, things of that nature. Now with the next one, it's Box 2D. That's another 2D physics engine, and that's used in popular games like Angry Birds or games of that nature. And it's known for its simplicity and effectiveness. That's all that is. It's pretty much renowned for it, to be honest. So that's Box 2D when it comes to Angry Birds, and I would I would badmouth Angry Birds, but if I did that, I would break the heart of my nieces and one of my nephews. So I'm gonna be quiet about Angry Birds and not say anything. Now, I want to also, from this point on, I want to talk about some of the advancements that have taken place in physics engines. Now, one of them is GPU acceleration. Um, Physics simulations are now offloaded to GPUs, and they're done. They do that for faster and more detailed calculations. Okay. Um, Now that enables real-time effects like large-scale destruction and fluid interactions and stuff of that nature. So there's been a lot of advancements in GPU acceleration. Now, also, I want to mention real-time destruction. Now, this is dynamic systems for breaking objects into pieces based on impact. Now, that involves chaos physics in Unreal Engine 5, and that's probably one of the leading examples. So um, that's real time destruction, or yeah, destruction, and it's also using chaos physics for anybody who's playing a game in Unreal, well, through Unreal Engine 5. So just a little bit of information there for you. Now, another advancement is in soft body and deformable object simulation. Um, there's improved algorithms for realistic simulations of cloth, flesh, and elastic materials that you can find on a lot of these games. And this is to add depth to character customization and environmental interactions and things of that nature. Like I was saying before, the leaves flowing or something floating on the water, things of that nature. So that right there is some advancements that have taken place with soft body and deformable objects simulations. Now, after that, you go to fluid and smoke simulations and the advancements that have been done there. Now, they've enhanced realism for water, lava, smoke, and fire. Games like Sea of Thieves, they really showcased advanced fluid dynamics. You can find a lot of advancements that have been put into that game when it comes to fluid dynamics. So now let me talk about virtual reality, the VR integration, and some of the advancements that's been made there. Physics engines adapted for VR uh, are done so to like ensure realistic interactions, and that's for like they're trying to uh, ensure realistic interactions in immersive environments. Okay, um, things like precise hand tracking and object manipulations, things of that nature, because that's pretty critical when it comes to VR gaming. And in a lot of the older ones, if you remember, anybody who can remember that far back, there, you didn't get very much of that. So that's some of the advances that's taken place when it comes to the virtual reality integration. after that, I do want to also kind of go over the AI driven physics, because that's something that is really happening in today's gaming world. It's a real deal. You know, I have my buddy Mark, who constantly argues about AI, and well, he argues about everything basically, but it's hard for old timers like Mark to understand, you know, that this stuff is real. It's here, and it's in the games. It's not a make believe thing, you know. And the advancements that they've done with AI driven physics is in machine learning, and machine learning is being used to like predict and optimize physics simulations. They're doing this to reduce computational overhead, and at the same time they're wanting to maintain realism, you know. So they're using AI in order to do this. um, then also you have to go from talking about AI driven physics to procedural destructive and generate generation, you know. Those are things like uh, for systems that dynamically generate destruction uh, based on like gameplay actions, you know. And I mentioned that just now, like destruction based on gameplay actions. That also, what they're doing there is they're making advancements in it, because what it does is it saves developers time by eliminating the need for like predefined destructive states. So when when that's what they're basically trying to do. They're trying to work on that and make it a little bit better and stuff of that nature. Okay, that is basically the the boring stuff that we have to get through. The description of all the physics engines and things of that nature that's taking place in the gaming world. Um, to me, it's not really all that boring. It's actually stuff that I've been dealing with other things that don't pertain to gaming. It pertains to like graphics and stuff of that nature. I really love making intros for the videos that I make, intros and outros, and I go into my Blender and I try to come up with cool concepts for it. And a lot of the stuff that I just reviewed is stuff that I've had to learn about in order to make those cool intros and outros. I've also done it for other things as well, like slideshows and things of that nature, and background videos that I want to put on my streams and stuff like that. So I was able to actually use a lot of the stuff that I just described to you in other areas of my streaming and stuff of that nature. So now I want to talk about applications in gaming. And the first one is about realism. Now, the thing about realism is physics engines make game worlds believable. That's what a lot of these games are getting into now. They want they want like accurate ballistics and shooters, you know, and then they also want like lifelike waves in sailing games, you know, things of that nature. Now, after realism, you know, there's the gameplay mechanics, the physics-based puzzles, you know, destructible environments, and ragdoll effects. They create a lot of engaging gameplay as well. Um, and then besides having realism and gameplay mechanics, you have immersion. Now that's advanced physics systems that enhance the player's connection to the game world. They do that by simulating natural behaviors. So that's what they're wanting to do. They're wanting to simulate natural behavior so that it seems real while you're playing it. You know, so these are some of the things that you need to think about when you're sitting there and you're playing the game. You know, like this is all the stuff that's going into the game when it comes to gameplay mechanics. You know, engines and things of that nature, physics engines. Now, physics engines are the backbone of realistic and dynamic game worlds. They continually evolve, and they are pushing the boundaries of what games can achieve, from GPU accelerated simulations to AI driven optimization. They're all integral to modern game development. Now, the difference between procedural generation and procedural generation algorithms is something else that I wanted to go through. Now, procedural generation is a high-level concept that refers to the method of creating data algorithmically instead of manually crafting it. This process is commonly used in video games, simulations, and other digital media to generate content dynamically. Now, for example, in games like Minecraft or No Man's Sky, procedural generation is used to create vast worlds, unique planets, or randomized levels without requiring developers to design each element by hand. Now, the primary focus of procedural generation is the outcome, the content that gets generated, such as maps, environments, or characters. It's a broad concept that includes the overall idea of using algorithms to create content efficiently and flexibly. It's widely applied to increase replayability, save storage space, and produce unique user experiences. Now, that is procedural generation. Now, procedural generation algorithms, on the other hand, are the specific methods or techniques used to implement procedural generation. These algorithms provide the logic instruction that dictate how the content is created. For example, algorithms like Perlin Nose are used to generate smooth and natural terrain, while cellular automata are used to create dungeon layouts. The focus here is on the process rather than the outcome. Procedural generation algorithms are technical in nature and require an understanding of programming, data structures, and mathematical principles. They determine the rules and constraints that procedural generation uses to produce its results. So that is the difference that is between procedural generation and procedural generation algorithms. I mentioned it before, so I figured I would go back over it and kind of discuss that because that really stuck out to me. So that's good to know for me, at least. Now, the key difference, the difference between the two lies in their focus. That's what you need to remember. Procedural generation emphasizes the result, the generated content, while procedural generation algorithm focuses on the method or process used to create that content. For example, when you see a beautiful procedural generated landscape in a game, that's procedural generation. But the mathematical and the computational techniques that made that landscape possible, such as Perlin noise or fractals, are the procedural generation algorithms, parts that you don't see. Okay, now how do they work together? Now, the two concepts are closely related and interdependent. Procedural generation relies on algorithms to function, while algorithms are the tools that make procedural generation possible. For example, in No Man's Sky, procedural generation creates billions of planets. Behind the scenes, algorithms like Perlin noise are used to determine terrain, while other techniques handle the placement of flora and fauna and things of that nature. Now, in roguelike games, procedural generation creates random dungeon layouts, while algorithms like random walk or cellular automata handle the specifics on how the dungeons are laid out. Procedural generation is what the dynamic creation of content. Uh, no, let me explain that better. It's the what. Is the what, the dynamic creation of content, and procedural generation algorithms are the how, the specific techniques and logic used to achieve that creation. So there you go. So procedural generation, we'll talk about that real quick. Procedural generation is a method of creating content algorithmically rather than manually, enabling dynamic, scalable, and often unpredictable results. It has a wide range of applications in fields such as video game design, simulations, art, and even scientific research. Now, by leveraging mathematical models and algorithms, procedural generation produces unique and often complex structures, patterns, or environments that might otherwise have an enormous amount of time and effort to design by hand. It might take a while to get there. Now, the key features of procedural generation is dynamic and scalable content. Now, procedural generation allows for the creation of vast amounts of content with minimal input data. Now, for example, in games, a single seed value can generate an entire world. Generated content can scale in complexity and size based on the algorithm's rules and constraints. After that, you have the randomness and the predictability. Now, procedural generation often uses pseudo-random numbers, meaning that the randomness is deterministic. Okay? If you have the same seed value, the output will always be identical, which is useful for reproducibility in gamings or simulations. After that, you come to the efficiency in development. Now, developers save time and resources by automating content creation. Now, for example, instead of manually designing thousands of unique landscapes, a procedural generation system can create them dynamically during gameplay. So while you're playing the game, it can just dynamically create the landscapes. After that, you have enhanced replayability. Games that use procedural generations like Minecraft or No Man's Sky or The Binding of Isaac often offer near infinite replayability because the content changes every time you play. This variable keeps experiences fresh and engaging in some of the games, other than Minecraft, of course. Nothing there is like uh, refreshing and engaging. Just putting it out there. Yeah, I'm harshing you guys on Minecraft. All those 6-year old griefers. That's all you are. You're a bunch of griefers. I said it. I said it. I'll say it again. I ain't scared. I ain't scared of you. Bunch of 6-year old griefers. Okay, so after that you have real time adaptability. No, I mean, I have no problem with bad mouthing a 6-year old Minecrafter. I'm sorry. I was going to let it slide, but there it is. You know, go tell your mama and your daddy. I don't care. Bunch of griefers. That's all you are. You're just a bunch of griefers. That's right. No, real time adaptability uh, is the next one I want to get started with. Now that's a procedural generation that can create content on the fly, and that's usually responding to player actions or environmental changes. A good example of that would be a dungeon crawler game might generate new rooms dynamically as the players progress through the dungeon. You know, so that's something right there that you can think about when it comes to real time adaptability. Now, types of procedural generation is terrain generation, and algorithms like Perlin and simplex noise are used to like create natural looking landscapes, including mountains and valleys and caves. Now, these techniques generate smooth, continuous variations in the elevation and the texture. So then you have the structure and the architecture. Um, Procedural systems can design like complex structures like buildings or cities. Games like Minecraft and Dwarf Fortress use these techniques to populate their worlds with believable structures. After that, you have character and asset generators or generation. Now, um, procedural generation can be used to create diverse character appearances, items, or even animations. And a good example of that would be Spore uses procedural generation to design like unique creatures and stuff. So after that, you come to narrative and quest generation. Um, in some cases, procedural systems create like storylines, dialogues, or quests. Games like No Man's Sky and Skyrim utilize this to enhance the player's experience with dynamic, branching narratives. So it breaks off into different areas and you can go on different quests and storylines and things of that nature. Um, and they are getting a lot more advanced than that. I really haven't broke into storyline as much as what I really should, but I have a nephew Jake who really gets into them, and I've been telling him for a while that I was going to go ahead and try to get into them because they're not like action games. You know what I mean? You just have to make a decision, and then the story goes on, and it'll tell you the story as you go, and it goes according to the decisions you make. So I find that interesting, but at the same time, I really haven't wanted to get into a game like that yet. But I've been saying that for a while, so I may just do that sometime here in the future. Now, after that, we go to environmental and ecological systems. Simulating ecosystems or weather patterns can also be achieved procedurally. These systems generate flora, fauna, and natural phenomena dynamically, um, and that's to make the environment feel alive. So that's that's some of the results of procedural generation. Now, what's the advantages of procedural generation? Most of this, I believe, is has to do with the people who make the games more than the people who play the games, really. And this is one of my whole thing where I get into a conversation about how games today have just gotten so much worse today, and there's a reason for that. Now, the advantage of procedural generation has to do with cost efficiency or cost affection. Effectiveness is another way of saying it. Now, for the people who are creating the game, procedural systems reduces the need for like manual content creation, which can be labor intense and costly for them. So that's one thing that is an issue. Now, after that, there's storage efficiency. Now, since procedural content is generated in real time, it eliminates the need to store large amounts of pre-designed assets. And for instance, No Man's Sky stores data for billions of planets in just a few gigabytes, you know. So that's kind of an example of it right there. Now, unpredictability and discoverability. Procedural generation creates opportunities for emergent gameplay where players encounter unexpected scenarios or they discover unique elements they wouldn't have find in handcrafted content. Which, yeah, that would be interesting. You know what I mean? If if but at the same time, I'd like to do like with Minecraft, where those areas that I've gone to stay there. You know what I mean? I don't want them disappearing. They should be there from that point on. Whenever I go back to that point, that's where it should be. So after that, you have customization or customizability, however you want to say it. That's for the developers, so that developers can tweak parameters to influence the generated content, and that offers a balance between control and randomness, basically. Um, there are challenges in procedural generation, and that's a loss of intentional design. Now, procedural generated content can sometimes lack the nuance and artistic touch of handcrafted designs, so you're not going to get all that good stuff. You know what I mean? It's just going to be a generated prefab, basically. The results might feel generic or repetitive without proper constraints, things like that. Also, debugging and quality assurance, that's the downfall. That ensures that procedural generated content works seamlessly, um, with the rest of the game or the system. That can be difficult as the variability makes testing uh, unpredictable. So unpredictability is a real bad thing when it comes to debugging and quality assurance. And this goes back to what I was saying too, with AI and all of these things, all that's going to go down the drain. You're not going to see quality assurance, and debugging is going to be a real big issue. So expect for that to take place. Because it's like I said, this stuff isn't, I mean, this isn't fairy tale. It's coming. I mean, it's coming. So get ready for it. Um, Also, the abundance of generated content can overwhelm players. For instance, No Man's Skies initially received criticism for its like vast and seemingly empty universe of nothing. You know what I mean? It was just an empty universe. So um, that's one thing that is going to be there too. Now, you also have computational costs. Real-time procedural generation can be resource intensive. It's going to require optimization so that it can to ensure like smooth performances and stuff of that nature. So that is the downside uh, to it, pretty much. Um, but or the challenges is the best way of saying it. The challenges. Now the applications of procedural generation beyond gaming. That's something too that I wanted to kind of discuss. Applications that are used outside of gaming that involve procedural generation is architecture and urban planning. Now, architects use procedural tools to design complex structures and urban layouts efficiently. Also, film and visual effects. Uh, Procedural generation creates like realistic environments, the textures and effects in movies. Uh, for example, films like The Lord of the Rings use procedural tools to like simulate massive battle scenes. You know, that's why whenever you see the big battle scenes, everybody in the background's usually all blurry and shit, and there's no face on them because it's they're generated. You know, so they put some randomization in there. Now, also, you have scientific simulations. Um, Procedural methods simulate like complex systems, such as galaxy formation or like fluid dynamics or ecological models, things of that nature. And also, you have it in art and music. You know, artists and musicians use procedural algorithms to create like generative art and music, often exploring like unique and unexpected patterns, things of that nature. So, um, when it comes to all this, the future of procedural generation has a lot to do with like AI and tech integration. Um, Now, combining procedural generation with AI will eventually allow for more complex and more meaningful content. AI can learn like player preferences and generate personalized experiences and things of that nature. Um, Now, also another thing to expect is hyper realistic worlds. You're going to see advances in computational power and algorithms that are going to enable the creation of like procedural generated worlds, and that's going to have also like unprecedented realism. So you're going to see a lot of realism, and you're going to see this coming out of procedural generated worlds. So that's the kind of stuff that you're gonna that's going to end up being the future when it comes to procedural generation. Now, procedural generation, it is a powerful tool that has transformed industries by enabling the creation of dynamic, scalable, and diverse content. Now, while it comes with challenges, its potential continues to grow as algorithms and computational technologies advance. Um, so, with that being said, I'm going to get into procedural generation algorithms. which are the specific mathematics and computational techniques used to create content algorithmic, algorithm, algorithmic, algorithmically, often in real time too. Now, these algorithms are the heart of procedural generation. They enable the creation of complex environments, characters, or objects, and they do it dynamically rather than relying on pre-designed assets. These algorithms generate content based on a set of rules or parameters, often producing unique, randomized, or infinite results. Now, how do they work? At the core, procedural generation algorithms use input parameters like seed values, noise functions, and randomness. And this is to produce output data. The key aspect of these algorithms is that they follow a deterministic process. Given the same inputs, they will always generate the same output. This makes them ideal for use in games or simulations where the same world or content can be reproduced by players or developers at any time. Okay. Um, the general process or procedural generation involves input generation. Now, this could be random values, often seeded. This is predefined parameters or even user input to some extent. Um, Also, you have algorithm execution. That's the algorithm process. Um, the input using its logic, its rules, and mathematic models in order to generate content. Okay. The next one is output. Okay, procedural generation um, involves output. The final test is content that may range from terrain, objects, or even complex narratives based on the parameters set by the algorithm. Um, Now, the different types of procedural generation algorithms. Um, I'll go ahead and give you some common types of procedural generation algorithms, and also how they work. Okay, first you have noise functions, and that's, for example, Perlin noise or simplex noise. Now, noise functions are mathematical algorithms used to create smooth, continuous, and natural looking randomness. They're especially useful for generating terrain, weather patterns, or other organic structures in procedural generation. Um, Now, I've mentioned Perlin before, but I'm going to go back over Perlin noise. This is one of the most widely used noise functions in procedural generation. It generates smooth, continuous randomness, often used to create terrains in games as well. Now, Perlin noise works by interpolating between random values in a grid to create like continuous values that vary gradually, giving a more natural look than like just purely random values. Now, you also have simplex noise. Now, that's a more advanced variant of Perlin noise. Now, simplex noise is computationally more efficient, and it can produce higher quality results, especially in 3D applications. Now, these noise functions help create realistic landscapes by generating varied elevations and textures like mountains, valleys, forests, oceans, and they mimic um, real world terrain basically. Now, that is one type of procedural generation uh, algorithm. And I wanted to break that down. But after that, I want to also talk about cellular automata. Now, cellular automata, uh, they are mathematical models used to simulate complex systems through simple rules applied to a grid or cells. Now, each cell's state depends on the states of its neighboring cells, and the system evolves over time. Now, the use for this in procedural generation, the cellular automata are commonly used to generate caves, dungeon layouts, or terrain features. The most famous example is the Game of Life um, algorithm. But in gaming, CA algorithms are modified to generate maze like structures or complex organic patterns. Uh, this would be patterns such as the random growth of caves or terrain features, you know. Um, a good example, or good examples actually, would be in roguelikes. Uh, Cellular automata are often used to generate like random dungeon layouts. Each iteration of the algorithm spreads out from the initial state, eventually creating corridors, rooms, and walls and things like that. Now, from there, I also want to talk about L systems, uh, Leiden-Meyer systems, basically. Now, L systems are a mathematical model for simulating the growth of plants and other organic structures. The system uses a set of rules referred to as an alphabet. It replaces symbols with other symbols recursively, basically. Um, Now, the use of this in procedural generation, the L systems are often used to generate realistic plant life in trees. Good examples would be by using L systems. Procedural generation algorithms can create trees that branch out into complex, natural-looking ways. You know, resembling how real trees grow, and basically stuff like that. Um, Now, good examples in games it would be like in games like Spore and No Man's Sky again. L systems are used to generate plants, trees, and like I said before, you know, other organic shapes that populate the game world. Um, Now, also, there is something called random walk algorithms. Now, random walk algorithms are based on the idea of an entity taking random steps rather than a defined space. Now, each step is made in a random direction, and the path taken is dependent on the randomness of each move. Now, the use in procedural generation is that random walk algorithms are often used for dungeon generation, um, where more rooms or hallways are connected by a random path. They're also used to simulate fluid like motion, like and growth or other organic patterns. Random walk algorithms are used in roguelike games to generate labyrinthine dungeons, dungeon layouts, where the player has to explore the environment, things of that that things in that nature, basically. Now, Voronoi uh, diagrams is something that I would be interested in because I've used Voronoi for other purposes and stuff, and I can tell you right now that that's really cool stuff to really get into. That's it's very, very good for textures and things of that nature. So this is one part that really stuck out to me. So let me just go ahead and kind of explain to you about Voronoi diagrams. Now, Voronoi diagrams are a way of partitioning a space into regions based on distance to a specific set of points. Now, each region contains all points closer to one particular seed point than to any other. Okay. Now, Voronoi diagrams are often used to generate maps where the space is divided into different zones based on proximity to a point of interest. This can be used for creating natural landscapes, city layouts, or ecosystems. In games like Civilization, Voronoi diagrams are used to divide the map into different territories, where each territory is associated with a city or a resource. Now, fractals is also something. Fractals are mathematic patterns that repeat at different scales. I'd really like to get more into fractals too. I've been studying up on it, but I haven't really gotten into it very much. I'm really interested in fractal math. And this is another thing that stood out to me. Now, fractals are self-similar, meaning the structure looks similar no matter how far you zoom in or in or out. So, fractals are used to create natural phenomena such as a mountain, coastline, or cloud formations. By using fractals, developers can generate terrains that have a self-repeating natural look to it. You know what I mean? So I think that's kind of cool. Now, Minecraft uses fractals to generate its terrain. It creates mountains and valleys that are realistic and naturally shaped. Yeah. I should have watched out for that one. Yeah, okay. So the advantage of procedural generation algorithms. Now, this is endless content. Basically, that's the first one. Now, procedural generations can produce virtually infinite amounts of content, which is particularly valuable in open world games or games with random environments. That would be like roguelikes. Um, now, I do have to emphasize something on that. Like with Minecraft, I said before that they've been able to generate a landmass the size of Pluto, the planet Pluto. But understand that this also goes according to the strength of your computer as well. I mean, they can try to beat that any way they can into it, but like there's just so much your computer can do. Now, if you're getting on that new cloud system that we've gone over, maybe you can do more. Maybe it'll take the stress off of your computer, but just understand that if you're doing the game, playing the game on your computer, it's only going to generate the amount that your computer can handle. So just be aware of that. I've been saying that over and over again, and I think that should be something that I need to mention. So, um, Now, the advantages of procedural generation algorithms is endless content, um, like I said, but cost effective is another thing. Now, this is for the developers and stuff. That helps the developers so that they can create large worlds. They can also create intricate designs or complex environments without having to like manually craft each asset. Um, this is supposed to save significant time and resources, and of course replayability, because procedural generation creates new and unique content every time. It enhances the replayability of the game. That means that players can return to a game and have a fresh experience each time, which I'm okay with, but I would also like to go back to the game and it be there. And I know that you can do that on Minecraft. So when I leave a game and I go back in, I want that area to still be there when I get back to it. So that's something that I really like about the autosave, because back when I first started gaming, we didn't have autosave. Um, so that was a good thing for me. Now, the procedural generation algorithms allow worlds to change over time, um, and that's dynamically generated worlds, um, or adapt to the player's actions. Um, Good example of that would be worlds can evolve based on the player input, which generates unique challenges for you and outcomes and things of that nature. Now, there are challenges for procedural generation algorithms too. And that's quality control. And we come right back to this. One of the biggest challenges of procedural generation is ensuring that the output is high quality. While randomness and variability are important, they can sometimes lead to results that feel unnatural, poorly designed, or unbalanced. And I've had a few friends who discuss this in in their gaming podcasts, and it's just the poor quality. It just seems like there's poor quality to it, and that would that would most likely be because of these procedural generation algorithms. They just give you that 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 horrible freaking unnatural, poor designed, and unbalanced look. You know what I mean? Now, another one that's challenge is over reliance on randomness. Too much randomness can make the content feel disjointed or incoherent. It's important to find the right balance between random generation and predefined structures in order to create like a consistent experience. Now, also another challenge is complexity of algorithms. Some procedural generation algorithms, like L systems or fractals, can be difficult to implement and optimize, requiring deep mathematical understanding and computational resources. Now, with the next one is going to be performance considerations. Now, real time procedural generation, especially for large worlds on complex and no or complex environments, can be computationally expensive. Optimizing these algorithms is crucial in order to ensure smooth performance. Now, procedural generation algorithms are powerful tools that enable the dynamic creation of vast, diverse, and complex content. They're essential in modern games, simulations, and digital media, offering significant benefits in terms of scalability, efficiency, and replayability. However, they can also come with challenges, particularly in ensuring quality and balance in the generated content. As algorithms continue to evolve, we can expect even more sophisticated and realistic procedurally generated worlds in the future. So I am going to stop right there because we really do have to stop. um, I a lot of this stuff is more of the technical stuff that's getting involved in it. I'm going through with some of the stuff that I started last week, and I'm breaking it down and kind of giving you an idea of what's going on here. This is probably the most technical part that I really wanted to go through. Like I said, this is a review or a follow up of some of the stuff that I had discussed earlier on. And what I wanted to do is go through it and kind of do a follow up on it. And after I end this, I want to go into some stuff that we haven't really discussed yet. And that is going to be the Nemesis system. And that, if you guys don't know, is a game mechanic introduced in Middle Earth, Shadow of Mordor, which came out in 2014. And I really did enjoy that game, so that's going to be pretty good. So next week when I come in and I do it, I am going to cover I'm going to start with the Nemesis system, and we're going to go deeper into it. And that's going to discuss things like, personalized enemies and things of that nature. So, with that, I am going to go ahead and end the episode. I want to make sure that you guys was able to see things or be able to enjoy whatever, you know. Now, with that being said, I'm going to go through and I'm going to see if there's anything that I have to, anybody made any comments. Now, there doesn't seem to be any comments on any of the streams. I got another spammer in the chat section for Kick, which I'm getting used to now, to be honest with you. But Dragus Production, thank you for making comments on DLive. I'll give you a shout out. If nobody's ever watched Dragus Production, you need to check him out. He has some pretty good stuff. That one of his shows is Censorship Sucks, and another one is Vixen's Vault. I keep forgetting the other one, though. It has to do with aliens and cool shit like that. So if you're into like cool shit like aliens and alien abductions, then you need to check that one out. It's Jack's show. I really like listening to him. So that's something that you need to check out if you can. You can find them on Rumble. You can find them on Twitch. Find them on DLive. I believe they're on X too. They also stream from Beam Studio, and I know they're on Kick. So they're on a lot of platforms. If you don't know how to find them, you're stupid. So that's basically all I can say. I mean, you're a stupid person if you don't know how to find them. Just type in Dragus Production. So, yeah, I said it. Just like I said it about the Minecrafters. Bunch of 5-year-olds. I ain't scared. I'm glad I said that too, by the way, because that's all you are. You're a bunch of griefers. You know what griefers are. I don't have to explain it. Bunch of little bitty griefers running around griefing. You griefers. So let me stop with my fight against little 6-year-olds and say thank you guys for watching the stream. And I will come back later and get a little bit more into this stuff and talk to you later.